All right, I'm Krisha Kennelly from ProMiles. I'm a technical manager on the AstroWare BrDR software, and I'm going to talk about the new advanced concrete member alts that we are introducing in version 7.1. So these new member alts will be available in version 7.1. They'll be available in girder system and girder line superstructure definitions. The new member alts can be either a reinforced concrete advanced concrete beam, or a post-tensioned advanced concrete beam, or a combination of both reinforced and post-tensioned if your tendons do not extend along the full length of the girder. As part of these new member alternatives, we are introducing post-tensioned I-beams into BrDR, and also this new feature allows some increased modeling capabilities for multi-cell boxes that maybe you have a situation where the full box, multi-cell box superstructure definition isn't flexible enough for what you need to model. And these new features are funded by Caltrans and the task force. The new advanced concrete member alts support a wide variety of cross sections. On the left side of this slide, you see like a standard precast beam shape, and then on the right side we show a non-symmetrical cross section that you can model using these new cross sections. New post-tension features that are available for these new member alts include the ability to have overlapping tendons, partial length tendons, and then you can specify the stage for applying the post-tensioning. So this schematic of the girder profile shows overlapping tendons. Partial length tendons means that you have a tendon that does not extend over the full length of the girder, as shown here. So the region where your tendon exists will be spec checked as per the post-tension spec articles, and then the other regions where there are no tendons will be spec checked as reinforced concrete. And then this slide shows the tendon profile definition window where you can select the stage in which you want to apply the post-tensioning. Now I'm going to walk through some of the changes that we've made in the user interface. This is the girder system superstructure definition window. So the first change you'll notice is a new member alt type that is introduced. So that's the post-tensioned. And then the second item you'll notice is there's a new modeling radio button selection at the top of the screen. So any existing girder system superstructure definitions that you have, when you migrate to 7.1 or when you import an existing bridge into 7.1, all of your existing superstructure definitions are by default, they're going to become multi-girder systems. In version 7.1, when you create a new girder system superstructure definition, you can select these radio buttons here. If you want to define a multi-girder system, like our typical girder systems you've seen in BrDR, and there's a new selection for a multi-cell box, and that's where you are modeling each girder, that when the girders are all put together, they model a multi-cell box. And I'll explain that in more detail as I go through this presentation. Once you create a girder system superstructure definition and you click the OK button, the next time you open this window, these radio buttons will be disabled with whatever your selection was. So you're not able to switch back and forth between the two structure modeling types. So this is a typical section schematic, which is for a multi-girder system. So you have your beams underneath the deck. This just looks like the typical girder system superstructure definition that we've seen in BrDR for the last 20 years. These members that are shown here, they can be of the new post-tensioned or reinforced concrete, advanced concrete member alternative. And then this window here, this is the structure typical section schematic for a girder system structure definition that is modeled as MCB. And here you can see we don't have a deck sitting on top of the girders. The top flange of the girders acts as the deck, and then these individual beams can all be put together to model a multi-cell box. We have similar changes in the girder line member window. So the girder line member window has a new modeling type. Any existing girder line members that you have, they will be migrated or version conversion over to an open girder modeling type. If you create a new girder line member in version 7.1, you'll have the option where you can pick between an open girder or you're trying to model a multi-cell box. Once you make a selection here and click the OK button, when you open this back up, whatever you have selected will be disabled and you cannot change it. So just like with the girder system, you can't switch back and forth. So if you were to select multi-cell box for the modeling type for a girder line member, you'll see down here at the bottom, there are some additional details that you would enter. And as I go through this presentation, I'll describe how this new data that you're entering for these girder line members, the software is actually going to be able to compute the live load distribution factors for you. Even though it's a girder line member, along the way of entering your data, you'll enter enough data that distribution factors can be computed for you, or you can enter them yourself if you want. You might be wondering, why introduce this multi-cell box modeling? It improves the modeling capabilities for multi-cell box. So if you have a multi-cell box that maybe the current multi-cell box superstructure definition in BrDR, within that structure definition, you're just describing the full box, and you may have some portions of your structure that are unique in certain areas, and you just don't have enough flexibility in that superstructure definition to describe what you have in your real bridge. So by providing this feature for a girder system, and you're defining each girder or web line individually, you get some extra modeling capabilities that you can't get with a full box. In addition, in a girder system modeled as MCB, the tendons are defined along each member and not the length of the full box as they are in a multi-cell box superstructure definition. So you get some extra flexibility there to be able to analyze and spec check webs that have differing web lengths. As part of introducing these new member alternatives to the girder system superstructure definition, we're able to get post-tensioned I-beams into BrDR, with minimal effort. Like they're sort of just coming along for the ride as the as this new feature is being implemented. So for the post-tensioned advanced concrete beams, the new post-tensioning features like overlapping tendons, partial length tendons, and choosing the stage to apply the post-tensioning, that ends up being useful for both the post-tensioned I-beams in a multi-girder system and then modeled as multi-cell box beams as well. So going back to the user interface to review some of the changes that you'll see, if you have a girder system superstructure definition that's modeled as multi-cell box, when you get to the, when you get to the framing plan detail window, you'll see that the diaphragms tab looks a little different than it does for a normal girder system. When you're modeling as MCB, instead of having the diaphragms tab as in a girder system, there is the interior diaphragms tab that you would see like in a multi-cell box. In addition, on the structure typical section window, there is no deck applied on top of the beams when they're modeled as multi-cell box. So this window looks a little different. It looks more like this window in a multi-cell box superstructure definition, where you have just some sacrificial wear and then a structural overlay that you can put on top of your multi-cell box girder members. Now I'm going to talk about the actual new member alternatives that we're introducing. So if I have a girder system or girder line superstructure definition that is modeled as a multi-girder system, when you click to create a new member alternative, you will see a new material type that shows up, the post-tension concrete. And then the girder type is advanced concrete. And then if you select reinforced concrete as the material type, there is a new advanced concrete, reinforced concrete girder type. And then if you have a girder system or girder line structure and it's modeled as MCB, when you click to create a new member alternative, you have two choices, the post-tensioned member alternative or the reinforced concrete new member alternative. So this is an example of the tree for a post-tensioned advanced concrete member alternative. Over here on the left side of the screen, we see that we're modeling as a multi-girder system. And this is what the tree looks like. And then you'll notice that when you're modeling as a multi-girder system, you can have a deck and a haunch profile described for sitting on top of your member alt. Over here on the right side of the screen, if you've selected multi-cell box, there is no deck or haunch that is defined on top of the member alternative. The top flange of the member alt is considered, to be the deck. Oh, too fast. Okay, so these new advanced concrete member alternatives, they are defined by defining cross sections and then assigning those cross sections to regions along the length of the girder member. So we have two types of cross sections that are available: a cast in place and a precast. Either of these choices can be used for post-tensioned and reinforced concrete. Just because you pick precast I as your shape, that doesn't mean that it has to belong to a post-tensioned member alt. You're just copying over the dimensions of the shape, and you can apply post-tension tendons to it if you want, or if you don't want to. And it could be reinforced concrete and vice versa. So this is a cast in place cross section. It has a wide variety of data that can be input. If you have a section like is shown here that is not symmetric, all of these edit boxes are enabled, and you can enter whatever data you want to produce the shape that you want. You can click the symmetric button, and then the right side will end up being disabled and will match what you've entered for the left side. So that if you do have a symmetric shape, you don't have to enter, the other half of the beam. It'll just be made symmetric with what you do enter. So that's the cast in place cross section. And then this is the precast cross section. This has less data entry, and it also has the ability to copy the dimensions from the pre-stressed shapes that you have in your library. So if you click this button, copy dimensions from library, it opens up a window that shows all of the precast shapes, the PS beam shapes that are in your library. And you can pick one of them and click the OK button, and then that data will get copied into this cross section for you. And then this is an example of a schematic that is available. Okay, as I mentioned, these new member alternatives are described by creating cross sections and then assigning those cross sections to regions along the length of the member alternative. The depth can vary. It can be constant depth or no depth vary, linear or parabolic concave. If you have selected on your girder system or girder line that you are modeling MCB, then you will see this column here where you can check that in this length of the range, the cross section should be considered as a solid section. And that's similar to like the multi-cell box where you can have the solid sections along the length of the beam. So that only shows up if you're modeling MCB. This is the post-tensioning tab for the cross-section ranges, and this is where you you assign your tendon definitions to locations along the length of the beam. And there is a schematic that is available for the profile of the cross-section ranges. So you can see how your cross-sections vary along the length of your member, and then you can see how your tendons are assigned to your member. Flexural reinforcement for the beam is entered in the flexural reinforcement window. There's a tab for the top flange and a tab for the bottom flange. And this is where you would enter your schedule of reinforcement along the length of your beam. And there is a schematic that is available, a plan view of the rebar in the top flange and then the bottom flange for the flexural reinforcement window. The new advanced concrete member alternatives allow you to specify the stage in which a hinge is present. So default is all of the stages, or you can be selective about what stage you want to apply your hinge in. The shear reinforcement ranges window, the window that is shown here is if I am modeling as MCB, and you'll see at the top of the screen similar to a multi-cell box structure definition. You can pick if you want to input your stirrups relative to the voids or the center line of bearing. And then the voids are determined by where you have entered solid sections on your cross-section ranges window. So that's very similar to multi-cell box. And there is a stirrup wizard that is available for you as well. And then this is how the window appears if you are modeling as a multi-girder. The stirrups are defined relative to supports, and then you can check if they extend into the deck or not to make it composite with the deck, to make the beam composite with the deck. And there is a stirrup wizard that's available for you as well. Now I'll talk a little bit about the extra data entry that we have for girder line advanced concrete member alts that are modeled as MCB. And this extra data that gets entered allows the software to compute the live load distribution factors for you. So on the girder line member supports window, if you are modeling as MCB, you will see a new column here where you can enter the value of the skew at that support, and then the skew live load distribution factor adjustment factors can be taken into account when the distribution factors are computed for you. On the cross-section ranges window, if you have a girder line member that is modeled as multi-cell box, we have some extra columns here where you can use an alignment reference line to kind of line up your cross sections and locate the edge of the travel way relative to your cross section as defined by this reference line. And then this next slide shows, so you're in that previous window, you select the location of your alignment reference line and then enter a distance to the edge of the lane. So that lets the software be able to know the this DE value that gets used in the live load distribution factor calculations. And in addition, when you have a girder line advanced concrete member alt modeled as multi-cell box, the cross-section ranges window has a girder spacing tab where you can enter the girder spacing to the next girder, and then that gets used here in the live load distribution factor calculations. So when you have a girder line advanced concrete member alt modeled as MCB, on the live load distribution factor tab, standard and LRFD, the compute from typical section button will be available for you. And then if you don't enter your data here, it will be computed for you at runtime. All right, so let's talk a little bit about the analysis that's available for these new member alternatives. So if you have a post-tensioned advanced concrete member alt, you can do an LRFR or LFR rating. If you have a reinforced concrete advanced concrete member alt, you can do an LRFD design review or an LRFR and LFR rating. So, you know, exactly as you do in a regular girder system, you sit on the member alternative, and then you go up to the ribbon and launch the analysis button. And then you'll get the analysis and spec checking of that member alternative. So that's just like all the other member alts we have in the system. Very briefly, I'll talk about just a couple modifications we've made to the spec articles. We have a new article for computing the centroid of the tendon, now that you can have overlapping tendons along the length of the beam. So you'll see a new article here for computing the centroid of the tendon at different locations. In addition, the loss articles that are dependent on where you are at along the length of the tendon, those articles have been modified to consider each tendon and the length along the tendon for computing, like the friction and the anchorage losses. Since we now support regions that have tendons and regions that don't in the same member alt, you may see in some of our post-tension articles, if you are at the point where the tendon starts or stops, one side of the tendon will be analyzed as one side of the cross section at that tendon start and stop will be analyzed as reinforced concrete, and then the other side will be analyzed as post-tensioned. So you may see some new phrases in the articles that on this side, there's no tendon defined, so this article doesn't apply. So just throwing that out there that you'll see some different things in the spec articles. Okay, so lastly, I'm just going to go over some of the limitations in these new member alternatives. This is like version 1.0 of these new member alt types. So, maybe not everything has been implemented yet. So if you have a girder system modeled as multi-cell box, only the individual girders get analyzed. You can't sit on the structure definition and have all of them like put together and analyzed as a full box like you would in a multi-cell box superstructure definition. No changes have been made to pre-stressed beams in BrDR. And no tendon improvements have been made in multi-cell box superstructure definitions. That means the overlapping tendons, regions of post-tensioned and regions of reinforced concrete, and selecting the stage. Those have not been implemented in multi-cell box superstructures. And then there are a few structure types that are not supported that are probably worth mentioning. We do not support pre-stressing and then post-tensioning the beam. Spliced post-tension girders are not supported, and segmental construction is not supported as well. All right, so sorry about that. That wraps up my presentation on the new advanced concrete member alts that will be available in version 7.1.